Hello guys, welcome to my YouTube channel. In this video, we will talk about different ways available to measure the performance of our classification model. Okay. So let's say we have trained our logistic regression machine learning model to classify between two different classes. Okay. So how do we measure its performance? So we need to understand how well it is performing on the given data set, right? So what is its accuracy? So there are other things called as precision, recall, F1 score. In general, it is called as F beta score, but I can cover this in a separate video about F beta score. But in this video, I will talk about F1 score alone. Okay, and there is something called as AUC ROC curves. So in this video, we will learn first four steps. This AUC ROC curves I will be covering in another video. It will be another part of the classification matrix because it needs some in-depth explanation. Okay, so let's start with accuracy first. So how do we measure the accuracy of anything? Let's forget about the classification model or machine learning at the moment. But how do you measure the accuracy? Accuracy is how many things that we have got right out of all the available things, correct? So in general mathematics, we can say how many things we have got correctly. So correct numbers, right? Corrects divided by total availables. Correct. So this is a more general way to measure our accuracy. Okay. When it comes to machine learning, the accuracy has a different formula, but the concept remains same. Okay. So in order to understand the formula, before we get into that, we need to understand something called as confusion matrix. Okay. So let's see what is confusion matrix. Confusion matrix. So as you all can see, it is a matrix. So it is a representation of rows and columns. Generally, it will be like this. So we will have our actuals here, actuals and predicted. Let's say we are dealing with only binary classification where we will be classifying the given data sets into positive or negative classes. Okay. So actual, we will have positives and negatives, and also while predicting, we will predict some of them to be positives and some of them to be negatives, right? So if I just populate this table, let's say if our actual is positive and also predicted is also positive, it is called as true positive or TP. Okay, if our actual is positive but predicted thing is negative, right, this is called as false negative. Okay, coming to negative actuals, that is if our actual classification is negative but we predicted it to be positives, it is called as false positive. And if both are negatives, that is if actual is negative and also predicted thing is negative, it is called as true negative. Okay, so this is how a simple confusion matrix looks like. Now we can calculate accuracy using this confusion matrix like this. So accuracy is equal to true positives plus true negatives, right? So these are the actually correct classified data points divided by all the available data points. So all the available data points, that is TP plus Fn plus Fp plus Tn, right? So this is how we measure accuracy of any given classification machine learning model. Okay. So this is about accuracy. This is always expressed in terms of percentage. So in the end, you can multiply with 100 so that you can express it in percentages. Okay. So higher the accuracy, the better the model performance. Okay. So it's a general assumption. Now coming to something called as precision. Okay. We'll see what is precision. So coming to precision, so we have this TP, FP and all things, right? So we need to understand what is this particular row representing. Okay, so I'll just mark it. So TP plus Fn, right? TP plus Fn, this gives us actual positives, number of actual positives. Okay, and similarly TP plus FP. Okay, TP plus FP gives us what is it? Predicted positives, correct? So this is number of predicted positives. Okay, so in the same way, this Fn plus Tn gives us predicted negatives, number of predicted negatives, and likewise Fp plus Tn will give us number of actual negatives. Okay, number of actual negatives. So remember this. Now, in order to calculate precision is a more general English term is out of all the predicted positives, how many are actual positives? Okay, so how do we represent it with the help of mathematics and using confusion matrix? So what I said, precision is out of all predicted positives, how many are actual positives? Right? How many are actual positives? So if you write it using confusion matrix, it is nothing but precision is equal to, so out of all predicted positives. So how we can get all the predicted positives? So predicted positives is this term, right? TP plus FP, right? TP plus FP is number of predicted positives. So that will go into denominator, that is TP plus FP, and actual positives are our TPs, right? Actual positives are our true positives. So this is how you calculate the precision. Okay. Now coming to recall. So recall, let me just write a more general English sentence for recall. So it is given by out of all the actual positives, how many are correctly classified as positives? Okay. So again, out of actual positives, how many are correctly classified as positives? So if you just represent this now with help of confusion matrix, you can see recall is given by, so what goes in the denominator? Out of actual positives. So what are our actual positives? That is TP plus Fn, correct? So TP plus Fn are our actual positives. So in denominator we will have TP plus Fn, and the numerator, how many are correctly classified as positives, correct? So again it will be TP. Okay, so this is about recall and this is precision. So do not confuse, guys. So here precision deals with out of predicted positives, how many are actual positives, and recall deals with out of all the actual positives, how many are correctly classified as positives. So precision deals with predicted positives and recall deals with actual positives, right? So that's the main difference. Now, since we have these two different numbers, precision and recall, it is better to club these two numbers and arrive at a single number. Okay, so that is called as F1 score. F1 score, and this is a harmonic mean of precision and recall. Okay, so the formula for that is, if you guys remember the harmonic mean from your high school days, the formula is given by 2 into precision into recall divided by precision plus recall. Okay, so this is a single number representation of precision and recall both combined together, right? In general, our classification model, we expect to have high precision and high recall values. So in other terms, if we arrive at a high F1 score, then our model will be performing better. Okay. So there is another thing you need to know about type 1 and type 2 errors. So that can be taken from this confusion matrix itself. Okay. So the false positives here, right, at this particular box, the false positives, false positive is also called as type 1 error. Type 1 error. Okay. And similarly, false negative is called as type 2 error. So just remember these terms, because sometimes people will directly use type 1 and type 2 errors instead of false positives and false negatives. But it's better to have an idea what do we mean by type 1 error and type 2 errors. Okay. So what all we have seen? We have seen accuracy, what do we mean by precision, recall, and F1 score. Okay. So in my next coming video, in another video, I will talk about AUC and ROC curves. Okay. So that's it for this video. If you guys have any questions regarding this, please post it in the comment section. I will try to answer you in the same way. Okay. So till we see in the next video. Thank you. Bye bye.